we are all very busy in our daily life, and time just passes by, and it's sometimes very important to take a step back and really reflect back on some of these key things. It's not just this session, but it's something on the flight, or every Friday, a couple of hours that I do, is to reflect back, what have I done this week, and where are we going? It's so important. It's what I call the e-cigarette moment. Today, the people who had invented the patents of e-cigarettes went to those big corporations and they said, "You're kidding me? E-cigarette patents, go away." The same people are now making $150 million on licensing. So what is our e-cigarette moment? That something that you cannot think about, Roger was talking about. That is what inspires me to be here and talk about the software-defined car. This is what I believe could be the e-cigarette moment of the automotive industry. Roger talked about distributed X. This is a sort of distributed X where software defines what your vehicle is. It is not about connected car. It is not about intelligent connected car. It's not about autonomous car, semi-autonomous car, self-driving car. Keep on giving a lot of brands, but underlying theme is the software that defines the car and its ability. And the opportunity that both from the operational efficiency as well as creating new value, enabling new business models, that is the power of the software-defined car. So what I'm going to talk about is how it changes everything, because it has the power to change the way we live, we commute, but it also has the power to change all the players involved, how the cars are conceived, what the implication is to the OEM and towards the entire supply chain. And so how do we come here? It's always very important to reflect a little bit of the journey of the automotive. So this is from the IEEE spectrum, and it shows line of codes for the automotive. I'm sure all of you here knows how many line of code are in a current smart car. But just to give a quick reflection, we are looking at about 80 to 100 electronic compute units, distributed computer within the car. Today, average smart car has somewhere between 100 and 200 lines of code. What does line of code really mean? It means software. What does software really mean? It means programmability. It is a platform. It's not anymore a vehicle, it's a platform. And platform allows you to think what you can do. Obviously, you have to reduce the cost of things that are happening today. That's one part of this. The other part is opens up new opportunity. So the power of the software-defined car is exactly where you have lots of line of codes, software, programmability, and ability to make that as a platform so that you can build new services as you go along. As you know, the car industry, when you get a new car, it's already 2-year-old software. And after 3 years of your lease, if you're leasing it, it's already 5-year-old software in your car. And if you're living in the cyber world, in the software world, then you know how many iterations of applications have evolved over these 5 years. If you're from the semiconductor network industry, you probably live by Moore's law, which says doubling every 18 months. So by 5 years, just 5 years, which means 3 years from the new car. Doesn't it sound cool? 3-year-old car, is it new? It's new, right? But its software is 5 years old, and it's not updated. If 18 months is doubling, in 5 years, you have 2 to the power 3. It's 8 times improvement in the social media, your smartphone, and everywhere compared to your car. Doesn't your car head unit look like an antique? Like, why can't we do this? We can do all these things. So that brings me to this key fundamental element that is really enabling this disruption. Now, everybody will say connectivity, we get connectivity, but it's not only the basic connectivity, it is also the Moore's law, driving the physical size of the silicon down, following Moore's law. It's also driving the communication cost down, broadband coming over there, Internet of Things, enabling new things, collecting data, ability to collect data from anywhere, everywhere, was not possible. It's possible because we have very low cost of connectivity through sensors and actuators that allows us to collect the next level of things, which is through connectivity, collect data, and a lot of the opportunities that will come in there. Next is cloud. It's the greatest democratization of IT infrastructure. There is no big advantage of being a big company versus my company. We can do the same thing as any big company can do at the same pace with as unlimited computing, storage, and network power we need. It's a level playing. It's very important, and the apps capability that cloud brings. The next one, maybe not that obvious to you, is context. What does it mean to me now? Context awareness. Not a swamp of data, not all the data, but what does it mean? You are already beginning to see some of the values of the context on your smartphone. Suddenly it says, hey, you need to head towards the airport because there's a traffic rush. So it crawls through your emails and tells you, hey, this is relevant for you. When you do a traffic search, it says for you, these are the routes. It's location-based, context-aware. Well, how does that happen in our industry is when you have a separation of hardware and software, you are able to make the software applicable for you. And that defines the foundational thing that is happening. It is called software-defined anything, which is like Rogers distributed X, software-defined X. You can do. We have seen the power of software-defined radio. That's what the cell phones are all about. We have ability to go across the continents and have the same cell phone, and that now 5 billion people are there. Then we saw the same trend in the networking, where I came from, software-defined networking. It's revolutionizing the networking industry. Same thing is happening in the data center, software-defined data center. The x86 blades are x86 blades, but it's the software that is defining what the data center does. The next game is software-defined car. The car is a car, piston is a piston, or electric vehicle is electric vehicle, but the software will define the level of autonomous capability, also the new business opportunity that will open up, and which I will talk about it. But let's look at the opportunity right now. So this thing of ability to change software on the vehicle, and vehicle being the basic platform. The basic fundamental thing is there's two things you have, whatever business model it is. Either you are improving the operational efficiency of today's, how you do, can you do it better and cheaper, or you're creating a new value. There's only two buckets. Either you're creating new value, or you're disrupting the old things and making it simple and better and cheaper. According to the IHS, just making the things that you do today, taking the car to the dealership, the cost savings to our customer, OEMs, is about $35 billion in the next 7 years. Just by doing a software update instead of taking it to the dealership for a patch or some ECU updates. That's the power of the OTA update, over-the-air update to the car. Security patch. We have seen how Tesla did the patch update compared to some other vendor who has done USBs and recalls and 7 months to finish that process. Don't know how many people have done it. The case is in front of us. We don't need to do an hypothetical generic use cases. On the top right, it shows the volume we're talking about of recalls. It's in millions, tens of millions. And if we continue the same way, it will continue to be the same number. But look at, so those are the top two, are the operational. At the bottom, you see how it creates new value creation. Tesla did this insane mode, where basically turn up the engine power and you can go 0 to 60 miles in 3 seconds. That's a feature. You woke up next day, you update it, and you have this great feature in the car. Fantastic. Now they're going to come up with highway auto steer, so semi-autonomous vehicle in the highway, automatic parking. These are new value. We didn't have those. These are new value creation. And I can foresee that down the road, these will be some of the features, functionality that we will be paying down the road after having the car. And the OEMs don't have to think, I have to have all the features and functionality before I sell the car. You just need to make sure it is super safe and it is reliable hardware and software will come. It's a mindset change. It also is not OEM, it ripples through the entire supply chain. How does the tier one, how does their supplier have to think about it? How do they bring software practice into their business? How do you do patch? Software security patch. How do you do it on immediately? How do you contain that security? All these are very important. So the opportunity in front of us is huge. So if you look at software, which is really updating the vehicle, but there's also the reverse direction. If you have the data from the car, what else could you do? It's not one-way stream, it's a bi-directional. That's what platform means. Two-way, closed loop. So if you were to get the data, you could make a 2x2 matrix. Typical BCG stuff, 2x2. So on the horizontal axis, you have data on the move, a data transition data, a data on the fly, here and now. And on the other side is data on rest. You have collected those data, you have all the time in the world stored. And then you can run analytics. On the vertical axis, Roger talked about scale. Individual, but also at the scale. You have two different axes. So personalization at the bottom, it's my car, it's about me, but also collectively as a group. Now you could plot almost any use cases related to data on this matrix. And the way it would look would be something like this. I'll just build it out. So you can think about individual car and real time, here and now. The value of that data right now for mine has a different type of use cases. The real time now, but collectively as a group, as we are heading towards, has a different use cases. Stored data, and you can use to do prognostic, diagnostic analytics, and do proactive recalls are the different use cases. And real-time historical data would be something like Amazon. Yeah, you bought this or others bought that. Why don't you buy this? So you can plot. This has the power of plotting your use cases based on real-time data, stored data, personalized individual car to a group of cars in a geographic area. And they have a different monetization value. And that's a very important. Not all data are equal. Not all data have the same monetization value. The value changes with time. That's a very important thing. Data value changes with time. When and how you use the data and for what application has a different monetization value. I think that is a very important as you think about the use cases. And no opportunity, all are rosy, no opportunity comes without risk. Thank you. So let's look at the risks. Obvious. The risks are well in front of us. Everybody has been talking about it. I don't think I need to iterate the risk. You see, even today, PCs and laptops, we still have malware. We still get hacked. So it's not uncommon. But one thing, what is not acceptable is in the vehicle, because it's about us. It's about life and death. It's about our kids. So there is a subtle difference. But to see and learn from the other industry is very important. But we will get hacked. So what is that security discipline and the practice you need to bring? We had, I don't know if you remember, we had for a long while, we had a software first strategy, a lot of companies. Then for last 5 years, we had mobile first strategy. Do whatever you do, make sure first it is applicable for mobile, then for any other thing. It's time. I say it's time to move to security first strategy. And especially if you're doing business in automotive, you better make security first strategy. And that basically has 4 principles. Prepare, detect, contain, and prevent. Preparation is very important. Preparation means across your entire supply chain, not in the car. you have to move all the way Nord Stream. Who are your suppliers? Each one of them have to have a software discipline practice of doing some vulnerability testing. They should be able to collect the data so that they can do in the back end proactive update. They need to come with a discipline of code updates or proactively. Detect, it's very important to detect in the vehicle all the anomalies, hotspots of attacks, and how to contain them. Containing them is very important, because if you get attacked, why should it spread throughout your entire car? You need to think about how to localize that breach, security breach, and do a quarantine on that level. Don't let it spread all over. So ability to isolate those events and quarantine them is very important. But one thing for sure, you will be breached. And so you need to have a prevention strategy. And that prevention strategy is going to be what is called a software update. Ability to send a patch for a secure environment, safety environment in a reliable way. This is very important. So with this discipline, I just want to say that it's all about connected ecosystem. We are all connected. Every component of this are all connected. And the value lies in the data. Without data, we will not be able to have a proactive management of security. We will not be able to unleash the true value of data. And it also has implication on the architecture. This architecture will have implications of not only having a proactive security patches and updates, but also will unleash the true value of data and change the business model. It will have a change of the consumption and monetization model. It will enable better car sharing. It will enable better collaborative economy like Uber, Lyft, because it's all data driven. The ownership of the data of the car moves to the OEMs who are building it. People will take car as a service, not owning the car. You won't be having an insurance. It's someone else. It's the OEM. You are just paying for what you need. So number of cars will decrease, but the number of miles will increase. We will rely, but we need when we need it. There's no point my car sitting in the parking garage in the office for 8 hours till I'm working. It's a high valued asset with a lot of compute just sitting idle. That waste of economy is going to change. So it's a OEMs have to think from selling car to selling mileage. That's what it requires when you have a connected ecosystem, when you have the data that goes through this. And this is the power of bringing data analytics, security, software update, and over-the-air update and collecting over-the-air, both bidirectional data is going to be key for the automotive industry. So with this, I want to thank you. Thank you.